So you want to conduct a chi-square test of independence using Microsoft Excel? Great! If you've watched our video that explains the concept of chi-square, you may recall the example of the four corners activity, and that the chi-square test counts the number of people in each category. The number of people in each group is an example of the observed count in the data. The chi-square test then compares these observed counts with expected values for each category. To get started with this analysis in Microsoft Excel, we have to first create a worksheet that contains both the observed counts and the expected values for each bivariate category. In the conceptual video, we provide the example of boys versus girls and whether they would come back to a similar event in the future. The contingency table, or table of observed counts, for that example showed the number of girls who said they would and would not come back, and the number of boys who said they would and would not come back. In this example, we are going to compare gender and awareness of STEM due to festival attendance. The question asked festival attendees, did today's event make you more aware of how STEM is part of your daily life? In this example, gender is the predictor variable. We want to know if it predicts different patterns in awareness of STEM. Awareness is our outcome variable. It is the variable that we want to learn more about. Here is the worksheet containing the data we will use to conduct the chi-square test of independence. These are the observed counts from the EvalFest data set. Next, we need to create a table of expected values. First, we need to copy and paste our table of observed counts. We will use this duplicate table to compute the expected values. Let's label this as expected. Next, we will clear out the crosstab values in the expected table. We want to leave the total counts as we will use those to compute the expected values. In order to compute the expected values, we need to multiply the column total by the row total and divide that product by the grand total. We will do that for each crosstab value. Once we've computed the expected values, we can run the chi-square test that compares the observed counts and expected values. The chi-test function in Microsoft Excel conducts a chi-square test. Type equals CHITEST, open parentheses, then highlight the observed counts, type a comma, and highlight the expected values, type close parentheses, and hit return. This computes the p-value associated with the chi-square test. We can label this p-value. If the p-value is less than 0.05, then that means you have different patterns in your outcome variable based on your predictor variable. You can look back at the data to make more specific statements about how the variables relate. In our example, when we look at the percentage breakdown of awareness by gender, we can see that the percentage of females who said that festival attendance made them more aware of how STEM is part of their daily lives is significantly more than the percentage of males who indicated that festival attendance helped to increase their awareness. Interpreting the results of a 2-by-2 relationship is pretty easy because as one thing goes up, the other goes down. Things get a bit more tricky when you have more than two groups.